Okay, trial and improvement for this equation here. It says a solution exists between 3 and 4, and you're going to use this trial and improvement method to find an answer correct to one decimal place. So the first thing you do is you try values, right, between 3 and 4, okay? And where you should start is in the middle of 3 and 4, right? So you need to do 3.5. Now, what I would do now on my calculator, right, I would set up this on my calculator so that I can input these values of x, all right? And what I'm always going to set up is I'm going to put in a bracket to represent that x value, right? So it'll be bracket cubed, take away 2 bracket, okay? Because remember now, 2x means 2 times x, so I can use a bracket to represent that, and minus 45. Now, you know, you're looking at this now and you might think, well, what's going on here, right? I don't understand this. Well, the idea is, as I said, you need to try values between 3 and 4, right? And we go in the middle to start with, 3.5. So if I set this sort of this equation up, right? So I'm going to use a bracket so that I can input my x value. So 3.5 to start with, and I've got to cube it. Take away 2 bracket 3.5, okay? So for the 2x there, minus 45, okay? And as I said, I always use brackets because it's clear to me, I know where the x values are, right? And I press equals and I get minus 9.125, okay? So I put that there. And of course, we wanted it to be 0, and it's nowhere near 0, it's too small, right? So the x value that we used here is too small because it only gives us to minus 9, so we need to increase that x value, and we always increase by just one increment, right? So we go to 3.6 next. And what you can do now is, because they're in a bracket here and it's quite clear, press that back arrow on the replay button and just delete it and change it to a 6, okay? And we get, again, minus 5.544. Again, that x value we've used there produces an answer which is negative, right? So 3.6 is too small. So we need to try 3.7. Okay, so press the back button here, change that to a 7, change that to a 7, and I get this, right? Now, press the SD button, again, minus 1.747, again, too small an answer. So we need to try a higher value for x, we try 3.8. Okay, so go back, change that to 8. When I do that, of course, I get 2.272. Now this time, I've gone above 0, okay? So I've gone the other side. So actually now it's gone slightly too big, isn't it? Okay, but what's good about this is now 3.7 is too small, 3.8 is too big. So my answer is somewhere between those two, 3.7, 3.8, okay? But what's good about this is I only want my answer correct to one decimal place, okay? So we just got to decide, what is it closest to? Is it closer to 3.7 or closer to 3.8, right? You can't just leave it like this. If you leave it like this, you only get 2 marks. You have to decide, well, which one is it? 3.7, 3.8. And when I mean decide, okay, you've got to show your working as well, okay? So you can't just have a guess. You can't just say 3.7, right? Just because you think it is, right? You need to show your working, all right? And the way we go about that is follows. I'm going to show you. I use a little number line. Okay, and I put 3.7 in the end, and I put 3.8 on that end, and I know 3.7 is too small, 3.8 is too big, so what I do then is I go in the middle between those two. I always go in the middle between those two, and halfway between 3.7 and 3.8 is 3.75, okay, so I'm going to check what 3.75 is, right? So if I go back on here, change this on my calculator, and I get out to be 0.234375. Okay, now that is, of course, bigger than 0, so it's too big. So 3.75 is too big an answer, which means it's got to be smaller than 3.75, which means we've got to go this way. And if we go in this way, the answer then is closest to 3.7. Okay, so we can say 3.7, correct to one decimal place, is our answer. But to get those full marks, you have to look at those two values, the smallest and the biggest, and you have to go directly in between them and prove that actually directly in between them, that's too big, so we have to be closer to 3.7